right, today we are learning about logarithms. This starts on page 375, but I'll get you to turn to page 376. And the reason we have a logarithm is because the logarithm is the inverse of a power. Now, we've learned about inverses. You've seen a lot of inverses over the years. The first one that you probably learned was the opposite of adding is subtracting. And then over the years, you've learned different ones, like if I have x squared, what's the opposite of squaring? Square rooting. So the inverse of squaring is square rooting, and then you would get your answer. Now, the reason we have inverse equations is so that we can solve for x when we need to do the opposite. So we've learned a whole bunch of different things that are the opposites all the way through. Probably the last major one that you learned, well, square roots, but you've learned ones like this. What's the opposite of sine x? Sine inverse. It even has the word in it, right? So technically, you could take sine inverse of both sides. That will cancel out this, and you'll just have sine inverse of half, and then you'd get x is equal to 30 degrees, or pi over 6. Now, one of the areas up till now that you haven't learned the inverse of is when there's a power. So in yesterday's class, we were able to solve questions like this because you could get them to be the same base on both sides. So is 1,000 part of your powers chart for 10? Yes, it is, because 1,000 is 10 to the power 3. And then you could solve that x had to be 3. And if I took a 0 off of here, then you would change 100 to 10 to the power 2, and then x would have to be 2. But what would happen if we had another number there, 525? Can you see that x would have to be bigger than 2, but less than 3? So it's somewhere between 2 and 3. And if you're happy with that, then don't worry, you're good to go, because that's all you'd have to worry. But if you wanted to find it exactly, we would need something that was the opposite of doing to the power x. And that something is a logarithm. So graphing inverses, do you remember how to graph inverses from transformations way back? What happens when you graph an inverse? The y and x gets flipped. So if I've graphed y equals 10 to the x here, if I wanted to graph its inverse, instead of having the point 1 comma 10, I'd have the point 10 comma 1. And instead of the point 0 comma 1, I'd have the point 1 comma 0. So one of the things that you can now do is graph all logarithms. This graph right here is log base 10 of x. And log base 10 is a common log that's used a lot, so we often write that one as just y equals log of x. And another thing about inverses is inverses are always reflected over that green line. That green line is y equals x. So you can see that this graph here is just the flip of this one over here. Can you see that our original exponential always had an asymptote at y equals 0? When that gets flipped over, your log graph is always going to have an asymptote at x equals 0. So because x and y are getting switched, the same thing happens with your asymptotes. At the bottom of the page, we have our definition of a logarithm. And so what it's saying here, this is the important part of your definition of your logarithm, and we're going to do it with the example that we had before. So the example that I had before is I had 10 to the power x equals 525. The 10 is our base, the x is our exponent, and I'll call the 525 our answer. So the definition of a logarithm says that you can rewrite all of this as log base 10 of 525 equals x. So in other words, a log is just another way of writing an exponential. But what it does is it allows you to get the exponent all by itself. So some things to notice in the log definition, what number you write here is still your base. Log solve for exponents, so this is where your exponent goes. And right in here is your answer. But what it allows us to do is if we take out our calculator, is we can type this into our calculator now. And we can find out exactly what that exponent would need to be in order for it to work. Now on your calculator, you have two log buttons. There's a log button right beside the 7. This log button automatically has a base of 10. So for the one that we wanted to write, which was log base 10 of 525, we can now just type it into our calculator and find out that the answer was 2.7201. If we want to check if that answer was right, 10 to the power of that answer should equal 525. And it does perfectly. If you have a TI-83, the only base that you can do is log base 10. Okay? So if I wrote another exponent here, something in exponential form, 7 to the x equals 22. Mental math, tell me which two numbers, which two whole numbers that answer is going to be between. It's going to be between 3 and 4. What's 7 to the power 3? That's 7 times 3. Careful. 7 to the power 3 is huge. It's already like 300 and something. It's going to be between 2 and 1. Because 7 to the 1 is 7, and 7 squared is 49. So we know that this is going to be between 2 and 1. If we wrote this in log form, what's the base here? 7. So we would write a little 7 as a base there. The answer is 22, and logarithms always solve for the exponent. So if you have a TI-83, you won't be able to write this in exactly as it's written. If you have a TI-84 and you have the newest operating system, you can go alpha y equals, which is the same place that gives you the fraction. If you go over to function, the fifth one lets you write other bases. And if I go log base, then it automatically adds a space for me there, and I can put a 7 and a 22. And we find out that the answer is 1.59. If you have a TI-83, You can find this answer, and we'll learn how this works by doing log of 22 divided by log of 7. So if you want to write that down, you can figure it out that way. It's always log of the answer divided by log of the base. So this is the definition of a log. So it becomes very important to be able to know how to switch back and forth. All right, let's go to our example number 1. For 1a, they just want you to write those in log form. And for part B, take all of those that are in log form and write them in exponential form. So I'm going to give you a 1-minute head start, and then I'll put up all the answers. So there's the answers if you want to check how you did, or if you're doing them and done a couple but still want to do the other ones, I'll give you some more time to do that as well. And the questions which get you to use your definition are 5, 6, and 8.